In this question, we were asked to prepare a buffer at pH 4.8. We were given a selection of 3 different acids: formic, propionic, phosphoric. Each of their Ks is listed from the index at the back of the book, and from which we calculated the pKa. We were also told that we're given an equally concentrated solution of the conjugate bases of each one of the acids mentioned. So how do we prepare a pH 4.8 buffer? Well, when we take the pKa, we find out that propionic acid has a pKa very close to 4.8, 4.9. So we are going to use propionic acid to set up our buffer. We use the Henderson Hasselbach equation to determine what the ratio of conjugate base to the unassociated acid has to be. So we plug in the pH, here's the pKa. So negative 0.09 is equal to x, that's equal to the value of the log of the ratio. So we take the inverse log of that number, so we raise 10 to the power of negative 0.09, and it gives us x equals 0.812. So to make a 1 liter solution, now we let x equal the number of mLs of the conjugate base solution used to prepare the buffer. Then 1000 minus x will equal the number of milliliters of the solution that contains the propionic acid. We solve the algebra. The ratio is x over 1000 minus x, so this is the amount of A minus, and this is the amount of HX. Now you might wonder, why did I use concentrations? Well, because the concentrations are the same for both solutions, so they'll cancel out anyway. We do the algebra and find out that x is equal to 448 milliliters of the conjugate base, and that means that by difference, there are 551 mLs of the acid solution. So in conclusion, to prepare a buffer with a pH of 4.8, we combine...
Mr. Nopriato, line 101. Mr. Nopriato, line 101.
We combine 450 mLs of the 0.1 molar propionic acid with 550 milliliters of the 0.1 molar sodium propionate. This will produce 1 liter of the buffer, a solution which is reasonably able to withstand pH changes both by addition of acid or base, and the reason being is that it's close to its pKa value. Whenever the pH of a buffer solution is close to the pKa value of the buffer that constitutes it, then it will be resistant to pH changes in both directions.